Hello, this is Divya, working as an assistant professor, Department of Biomedical Engineering at Sri Sharma College of Engineering and Technology. Today, I would like to present the topic Superposition Theorem. So, statement of Superposition Theorem. This superposition theorem states that in any linear network containing two or more sources, the response in any element is equal to the algebraic sum of the responses caused by the individual sources acting alone, while the other sources are non-operative. Okay, so what this statement says, it says the circuit may consist of two or more sources. But if you need to find out the response in any element, the algebraic sum of the responses caused by the individual sources acting alone, while the other sources are non-operative. We have to make the other source non-operative. We have to keep only one source active. If you find out the algebraic sum of the responses caused by the individual sources, the response will be the same while all the sources are active. So that is by considering the effect of the individual sources. So how can we make the individual source active? How can we make the other sources inactive? So other voltage sources and other current sources are replaced by short circuit and open circuit across their terminals. So we have to, if it is a voltage source, you have to remove the voltage source and make it as a short circuit. If it is a current source, you have to remove the terminals and keep it as a open circuit. So this theorem is valid only for the linear system. It is not applicable for the non-linear system. If the system is linear, we can apply a superposition theorem. Otherwise, we cannot apply superposition theorem. So superposition theorem states that in a linear network containing two or more sources, if you want to find out response of an element, the algebraic sum of the responses caused by the individual sources. Steps to solve the superposition theorem. So the first one is we have to remove all the sources except one. So while removing the voltage sources, their internal resistance. If it is a voltage source, you have to remove the voltage source and you have to short circuit the terminals. If it is a current source, you have to remove the current source and make it as an open circuit as their internal resistance is infinite. So they should be replaced by the open circuit. So the next step is you have to find out current in various branches and voltage across various branches due to the single source. What we kept in the circuit is should be calculated. And next one is we have to repeat the process repeated for all other sources acting alone. Remaining sources should be inactive, should be taken one at a time. So finally, we have to calculate algebraic sum of the currents and voltage drop across the resistors due to the different sources is calculated. So let us see these steps in more detail. So what is our step one? We have to keep only one source active and another source inactive. Here, look at the circuit. We have two sources V1 and V2. So while making the source V1 active, I have to make V2 inactive. How can I make V2 inactive? By removing the source, voltage source V2, and you have to short circuit the terminal CD. So when V1 is operated, V2 is short circuited. So let I1 is the total current flowing through the circuit. V1 is operated alone. So I1 dash is the current flowing in the loop 1 and I2 dash is the current flowing in the loop 2. So then I1 is equal to I1 dash plus I2 dash. So apply KVL for loop 1. So if you are applying KVL for loop 1, so I1 dash plus I1 dash into R1 plus I1 dash plus I2 dash into R3, which is equal to V1, which is equal to V1. Or we can modify, we can simplify this equation, I1 dash into R1 plus R3 plus I2 dash into R3, which is equal to V1. Next, apply KVL for loop 2. So if we apply KVL for loop 2, what will happen? I2 dash into R2 plus I2 dash plus I1 dash into R3. So why I'm marking as I1 plus I2, I1 plus I2 in the equation number 1 and 2, because both the currents are flowing in R3. I1 dash, both I1 dash and I2 dash are flowing in the same direction. So I'm marking as I1 dash plus I2 dash into R3 is equal to 0. So if you simplifying this equation, I1 dash into R3 plus I2 into, so if you're taking coefficient I2, the term I2 out, so you will get R2 plus R3 as coefficient of I2 dash, which is equal to 0. By solving the equation number 1 and 2, you can get the values of I1 dash and I2 dash. Hence I1 is equal to I1 dash plus I2 dash can be calculated afterwards. So the next step is you have to make V2 operative and V1 as inoperative. While making V2, so what is the response? What is the current flowing through the circuit? We need to find out. So V2, while making V2 active, V1 should be removed and short circuited these terminals. So if we short circuit these terminals, you can get two loops, I1 double dash and I1 double dash is the current flowing through the loop 1 and I2 double dash is the current flowing through the loop 2. So after finding I1 double dash and I2 double dash, by summing up these two currents, you can get the value of total current flowing through this circuit. So first one is you have to apply KVL to the first loop. So if you are applying KVL to the first loop, so what is the equation you will get? I1 double dash into R1 plus I1 double dash plus I2 double dash into R3, which is equal to, there is no voltage source in the loop 1, right? So which is equal to 0. Or if you simplifying this equation, so what is the coefficients of I1 dash? Coefficient of I1 dash is R1 and R3. So R1 plus R3 plus I2 dash into, what's the coefficient of I2 double dash? Only R3. So you can write as R3, which is equal to 0. So this is the third equation. Next, in the same manner, you have to apply KVL for the second loop. So if you apply KVL for the second loop, so voltage across this R2 can be calculated as I2 double dash into R2 plus R3 into I2 double dash plus I1 double dash, which is equal to V2. Here, look at the direction of the currents flowing through the R3. Both currents I1 double dash and I2 double dash are flowing from up to down. So you can mark as plus. You can sum up the currents I1 double dash plus I2 double dash into R3, which is equal to, so the current flowing and the voltage source, current flowing through voltage source towards the positive terminal, so which is marked as V2. Okay, so if you if you simplifying this equation, I2, what is the coefficient of R3? So what is the coefficient of I1 double dash? I1 double dash coefficient is R3. And what is the coefficient of I2 double dash? R2 and R3. So R2 plus R3, which is equal to V2. So by solving the equation number 3 and 4, you can get the value of I1 double dash and I2 double dash. So after getting the equation values I1 double dash and I2 double dash, you can calculate I2, which is equal to I1 double dash plus I2 double dash, which can be calculated. And after finally the I1 and I2, by algebraic sum of the currents I1 and I2 due to the voltage sources V1 and V2 can be calculated. So that is what we need to find. Thank you for listening. Thank you.